Help me video for question 4, which is the option human musculoskeletal anatomy. There's a typical picture of the sarcomere, the name of a couple of the bands on. Identify the main proteins found in each regions. So you've got actin, which is the black, and the myosin, which is the grey on there. And this is dependent on your knowledge of, do you know, particularly these two are okay, but these two, do you know which of those are attached to? So the A band, so if we just, so in this A band here, what have we got? Well, we've got actin and myosin, but then can you remember what the other two are attached to? In a way, it doesn't really matter. If they're attached to the actin or the myosin, then they're going to be there. In the I band, which is this sort of area here, then we've got the actin and whatever's attached to it. Look in your notes, but we haven't got the myosin, so that shouldn't be there. Explain how the interaction between the actin and the myosin results in the contraction of muscles. Reference to the roles of troponin and tropomyosin are not required. So a couple of people have talked about that, and it says it's not required, so you're not going to get any marks for it. So interaction between actin and myosin. So telling us what happens between those, that's the interaction. You know, does anything move? Is anything used? What actually forms? Try and put some keywords in there. Then we've got an experiment. Muscle fibres which are contracting, and we can see them down a microscope. So then there's we've measured the lengths. These diagrams, you can't use those to measure anything really. They're just there to show you what this sarcomere looks like. And they're running an experiment, and again, it doesn't really matter what the experiment is, because it says explain why at least 20 sarcomeres were measured. Well, it's explain why at least 20 anything were measured in an experiment. Why would you do 20 rather than 3? And the answer is always going to be the same. Some of you have said the word accuracy, which isn't right. There's another word. So when you calculate an average or a mean, there's a word that describes the fact that you use lots of results. It makes the results more. Insert word there. Use a graph to calculate the length of the actin fibre. This is difficult. This is difficult to get your head around. I couldn't do it at first. On this diagram here, if we look at this diagram here compared to, that's the intermediate one, compared to say A. If you look at the end of the myosin, this moves the whole length of the actin. So the actin is this. So what's the question? The question is, what's the length of that? That's what we're trying to find out, the length of the actin. So the difference between A and C is this myosin is then touching this line, the Z line. So now there's nothing there then. So the difference between those two is the difference between these 2 points here. So when you look on the graph there, that's 3.6 and this is 1.2. So the difference between those is 3.6 minus 1.2. And then you've done that for 2 actins, so you need to divide the answer by 2. So not easy to do that. If you're staring at disbelief at the screen now, rewind it and listen to that bit again. But it's 3 marks, and so you're going to have 3 marks to the answer. If you miss the units, because there is some units that are needed there, then you get a maximum of 2. Imagine doing it all right and then forgetting what the units are. What are the units going to be? The units going to be those. Right. Psychologists conducting these experiments use tissue from the same organism. It's a kind of practical question, which is AO3. Suggests 2 other factors that need to be controlled. So these are controlled variables, and we need 2 of them. So in any experiment, think of the things you've done in the lab, or you've done experiments like with enzymes and things like that. What sort of things did you keep the same? And you shouldn't need too much further help with that. Suggest why there's no tension generated at C. Right now, there's C. So how do you get anything at all going on with these? Well, think of this overlap and this answer that you've had down here. So what needs to happen and isn't currently happening there? So what needs to happen between these two, the actin and the myosin, that isn't really possible with any force yet at that point. Part C, we've got a nice little set of tendons and muscles in the knee. Explain why skeletal muscles are arranged in antagonistic pairs. You need to say what happens to one in relation to the other. That's antagonistic. So if you're being antagonistic, you're being antagonistic to someone else. So say what happens to one muscle whilst the other one does something, and then then it might happen the other way around to move the leg the other way. Then we've got an experiment. So osteoarthritis, which you should know about, and the control group. Age is the same. Maximum voluntary contraction force. This is they asked the patients or the samples to push on something with their knee, and that number there is lower than that number there. So the control group have got more force, and the stair climbing time. Well, these guys can climb the stairs better than those guys. So the control group are more force, and so they can climb stairs faster. Refer to the role of the quadriceps. We need to say what that's going to do in the movement of the lower leg. Okay, that's going to be one of our marks there. Explain the difference between the osteoarthritis and control groups. Right, so first of all, tell us what the quadriceps is doing. It's a muscle, so tell us what muscles do, and that's how it's going to move the lower leg. Explain the difference between the osteoarthritis and control groups. So there's no difference in the age, there's a difference in the middle there, and that's affecting the difference at the bottom. You just need to put that into words. And lastly, we have BMI, body mass index, and again control group, their body mass index is better or lower than the osteoarthritis group, and it's giving us some information. This information we need to give back in the question to show that we've processed it. So values in excess of 30 are obese, and explain the effect of a higher BMI. So we're going to start off doing that, and then secondly, increase physical activity, reduce the impact and progression. So now we need to start thinking, right, I've got 5 here, but I don't want to fill the page, I need 5. So we need to start off by talking about this BMI and talk about this, obesity and these values. So if someone's got a higher BMI, then they're going to have to work out that muscle has to move more mass. So that's a problem, and you can predict what the effect on stair climbing time. So these guys are heavier, they've got less force, they've got to move more mass, and that's going to take them longer to climb the stairs. So put those into words. Then the effect of physical activity. Well, what's exercise going to do to the BMI? Because people will do exercise to lose mass, lose weight. Why do you go to the gym? You all go to the gym, don't you? Why do you go to the gym? What happens to your muscles when you go to the gym? Maybe I should go to the gym more. And the last two are, so those are 4 that you should get. The last 2 marking points are really just general points about exercise and what happens around the muscles around the joint, and flexibility, cartilage growth, and so on. Some general points about the benefits of exercise. And that's your 20 marks.